Another example with exponents is exponential decay. Let Y represent the mass in grams of radioactive strontium, which is 90 SR, whose half-life is 29 years. Now, half-life is this. You've got a radioactive substance that's giving out radiation that's causing people health problems, and a half-life of 29 years means whatever quantity of strontium you have, you'll have half of that remaining in 29 years. The quantity of strontium remaining after T years is given by Y, that's the quantity remaining, is equal to 10 times our base is 1/2 raised to the T divided by 29 power. Notice our base is 1/2. So our base is positive and it's between 0 and 1. That means we're going to have exponential decay. And of course, we're going to go through that point 0, 1, except that we have a vertical stretch by factor of 10. So what is the initial mass? Well, that means T is equal to 0. So Y is equal to 10 times 1/2 0 over 29. Well, 0 over 29 is the same as 0, and any number to the 0 power is 1. So Y is equal to 10 times 1, or 10 grams. Any kind of half-life problem is going to have 1/2 as the base, and the number of years for one half-life will be the denominator of whatever T is, and our initial amount will be 10. So with experience, you could look at this problem and say, oh, well, the initial amount is 10. Also think of it like this. Normally, we're through the point 0, 1. But we have a vertical stretch by factor of 10. So that puts us through 0, 10. And when we did our math, put in a 0 for T, we did get 10. Confirming what this looks like. It's exponential decay. And instead of through 0, 1, we've got this point 0, 10. So we could do that graphically as well. A different question, a little bit more difficult, is how much of the initial mass, we said that was 10 grams, is present after 80 years. Now, 29 years is one half-life. After one half-life, we're left with half of 10, or 5. Another half-life, 29 and 29, is 58. Puts us down to 2.5. So 80, if I did 3 half-lives, I'd be up at 97 years. So 80 is between 2 and 3 half-lives. So I'm guessing it's less than 2.5 grams, because 2.5 grams would be 2 half-lives. Let's see. The function value at 80 years, f of 80, would be 10 times 1/2 to the 80 divided by 29. Notice that's a number between 2 and 3. So this gives us, when I do it in my calculator, 1.48 grams. And I was expecting less than 2.5 grams, so I think I've got it right. I'm just modeling for you that you should always be thinking, does this answer make sense? And this answer makes sense to me. Graphically, I could do the same problem. Notice what happens after 29 years. I'm putting a 29 over 29 gives us 1. 1/2 of 10 is 5. So here's my point, 29 years, 5. If I do 2 half-lives, 58, if I put in a 58 here, then 58 divided by 29 is 2. So 1/2 squared is 1/4. 1/4 times 10 is 2.5. So I get 58, 2.5. That's how I knew at 80 that I'd be less than 2.5. If I put in an 80, we saw that that gave us 1.48 grams. Notice we still have a horizontal asymptote at Y equals 0. The implication of that being that once you have a radioactive substance like strontium, you're never going to get rid of it. It can get very small, but it will never be non-radioactive.